Assalamualaikum and hi, I'm Amirul Ilham bin Nur Syamani from Group 6. Here are the other group members. We have Nabila Huda, Iskandar Afiq and Muhammad Zikri. And the topic for our group is about the determination of metals in blood serum by atomic absorption spectroscopy (AAS). Okay, in this video, I will present my part. I have two part which are about introduction and also objective. For the introduction part, okay, what is serum calcium? Serum calcium can be defined as the amount of calcium in the blood that includes ionized calcium and anions, which can be determined by atomic absorption spectrophotometry. Okay, the function of serum calcium is to monitor bone disease or calcium regulation disorder. Okay, this method provide accuracy in the presence of calcium that release the principal which electron in outermost shell of atom that absorb radiant energy and become excited to form a narrow absorption line, which is within ultraviolet or visible spectrum. Usually, they present in protein that detected by hydrochloric acid inhibited calcium absorption that be evident the presence of lanthanum. Thus, it shown that the strong absorption of calcium was suppressed partially by hydrochloric acid and reduced anticoagulants such as oxalates, heparin, and citrates. And this involves some steps by repeated centrifuging, draining, and washing the acid, which then followed by titration process. It can be accurately measured by needing 0.1 to 0.25 ml sample of calcium content in blood serum by atomic absorption measurement. Okay, here is our objective, which is to determine the calcium content in the blood serum by atomic absorption spectrophotometry method.
Hi, my name is Nabila and I'm going to present the next part of the case study, which is the methodology. There are 4 major steps of determining metal in blood serum. The first major step is separate calcium by precipitation as oxalate. The second major step is the deproteinization by trichloroacetic acid. And thirdly is the direct dilution with water. And finally is the direct dilution with EDTA solution. The first step is to separate calcium by precipitation as oxalate. A 10 mm centrifuge tube is filled with 1.5 times its volume of an oxalate buffer. The tube was shaken and left to stand for 1 hour before being centrifuged for 10 minutes. The separated liquid poured off and the tube permitted to drain for 5 minutes. Upon dissolving the calcium oxalate precipitate with a drop of hydrochloric acid, 0.25 mm of strontium chloride solution is added. The solution was then transferred to a 5 mm volumetric flask and reconstituted with water. The solution was compared to standard strontium chloride containing calcium solution. The next major step is the deproteinization by trichloroacetic acid. In this next step, a serum of 0.5 mm was pipetted into a 10 mm centrifuge tube, followed by 0.25 mm of strontium chloride solution and 3.25 mm of water. 1 mm of trichloroacetic acid was added while stirring the solution, and the mixture was allowed to stand 5 minutes before being centrifuged. The liquid supernatant was compared to standard calcium solution containing sodium chloride, strontium chloride, and trichloroacetic acid. The third significant step is by a direct dilution with water. A serum of 0.2 to 0.5 mm was pipetted into a 5 mm volumetric flask, which was then filled with water. It was calculated in comparison to standard calcium solution containing sodium chloride. The fourth and final step is by direct dilution with EDTA solution. Serum of 0.2 to 0.5 ml was pipetted into 5 ml volumetric flask containing 2.5 ml of 20,000 ppm solution of the disodium salt of ethylene diamine tetracetic acid and filled with water. The solvent was compared to standard calcium solution containing 10,000 ppm sequestrol.
Assalamualaikum and hi madam, my name is Iskandar Fikri Abdullah. So for my part, I will present for the discussion and the result for the experiment. Okay, so basically this is the result for the experiment. There are several methods that are be used for the atomic absorption spectroscopy. Okay, so for discussion, based on the results, the B, C, D, and oscillate permanganate method were acceptable for determination of metals in blood serum by atomic absorption spectroscopy, except the A method, that is the calcium spread as oscillate method. Comparison between the others method and the A method is calcium content obtained by method A is slightly less than the other methods. For example, the average between the results of method A and method B is 1.8%. Next, the table earlier shows that the present work recovery of added calcium from serum by the precipitation method, that is the A method, was less than 100% compared to the other method. So this is why the first method is not suitable to determination of the metal in blood serum by atomic absorption spectroscopy because of the accuracy of the amount of metal in the method is less compared to others method by atomic absorption spectroscopy. So this is the overall discussion for the experiment. So that's all from me. Thank you.
And for the conclusion part, in conclusion, the atomic absorption method can be used to determine the blood serum calcium content with the sample between 0.1 to 0.5 ml. For the most accurate work, protein should be removed by coagulation. However, measurement can be quickly taken for routine purpose on solution of serum dilute immediately with water. The approach should be acceptable for determining calcium in other biological fluids since the interference by phosphate can be fully eliminated by the addition of a suitable suppressor and because cation interference are minimal. Some problem remains, but the atomic absorption method is at least as accurate as any other, has the advantage of speed and economy of material. And for the last part, the reference. This is a few reference material that we refer to conducting this experiment. And that's all from us. Thank you for watching.